path to network transformation, presented by Dana and MJ. A little bit information about them. MJ has worked with the DPDK team since 2009. MJ has authorized the DPDK cookbook as well. He joined Intel in 1991, has worked on various roles and divisions in Intel, including role as a 64-bit CPU front-side bus architect and a 64-bit HAL developer. MJ holds 21 patents, both individually and jointly, all issued while working at Intel. He's been awarded the Intel Achievement Award in 2016, which is the highest Intel honor on innovation and results. Before joining Intel, MJ architected CPU node board for 1,000 node machine design in India. And MJ won the gold medal for graduating with university first rank. Okay, then welcome, MJ. Thank you for joining us. Dana, a little bit about her. Since joining Intel in 2014, Dana drove the adoption of SDN and NFV in the communication industry through the introduction of new technology and marketing initiatives. As a product manager director in Intel Networking and Custom Logic Group, NCLG, she focuses on enabling network cloudification and assisting transition of communication service providers to new business and operation models, right? Throughout her career, Dana has held various senior product management, business development, marketing, and engineering management roles with leading companies addressing spectrums of areas in telecommunication and wireless communication industry. Welcome, Dana. So I will turn it over to them. Please.
Okay.
Thank you.
Can you hear me? Yeah. This morning I didn't have a voice, so now I hope I'll have one. So I'm Dana Nehama, as was introduced here, and I'm Director for Product Management for Cloud Networks, which mainly relates to work that we are doing in Intel in order to enable network transformation, network adoption, and this is what we are going to talk about here. And here we have MJ that I didn't know about him that much until the gentleman was telling about all his stuff, all his patents and so. What is it that we want to talk about? First, we want to talk with you about something which is called Experience Kit, and most of you may not know what is an Experience Kit, so I'll start with that. And then we'll talk about network transformation. Network transformation is here, network transformation and platform transformation, and what we are doing in order to enable this network transformation, which is actually through the adoption of tools like Experience Kits. And then we are going to talk about what we have to offer you as the Experience Kits to support your products, your product development, and understanding of how the industry may adopt best platforms in order to support the evolution in networks and in 5G, edge, etc. And then the last thing, we will like to open it for questions and answers so we can understand what are your concerns and how you may want to adopt what we are doing. So to start with, in short, what are Experience Kits? Experience Kit, and the reason it's called Experience and why it's a kits and not many kits, is that actually Experience Kit are a collection of collaterals. It's a collection of collaterals that can be in the form of application notes, of demos, of benchmark reports, of all kind of tools, of different type of software enabling, different kind of tools that we are offering in order to ease and expedite adoption of new technologies in products that are supporting networking. So this is the easiest way for me to talk about this. So if you think about this, it can be in the form of a reference architecture. So if you are about to have for your product, if you are about to introduce a POC or a lab trial or something like that, we are providing some guidance in the form of a reference architecture, of, for example, with potentially with some result, with some benchmark results that show you what we believe in Intel through the work that we are doing internally with the open source community and also with partner, we believe is a good way in order to achieve optimal results. And So that's just one of an example. We'll provide you with more details as we move forward. But first, so now this is what we want to talk with you about the experience kit, but let's give you also a little bit of background. What is the context of how we develop those experience kit, and what is driving this work here. So I'll talk about network transformation, because network transformation is a fact, is something which is happening. Now I think there is the previous talk was about CNTT and the effort of CNTT. So it's very clear that a service provider have new opportunities out there. 5G as well is around the corner, and with 5G there are more requirements for higher density, not requirement, but like there are more opportunities for higher density, higher data throughput type of services, and there is multiple opportunities that a service provider wants to offer in the form of new services, such as services in the edge. We are talking about IoT, about smart grid type of deployment, and so on and so forth. This is not new, I assume, to anyone here in the room. And as the network and the business is transforming, it actually requires a new network in order to support these kind of business opportunities. So when we are talking about network transformation, we are talking a transforming network which is more flexible, more agile, more scale. These are the things that I indicated here. And the meaning of flexibility is, for example, if it's about service providers wanting to shorten their life cycle management. It's about the ability to enable services in a faster way, in a much faster way. It's about the ability to scale platforms out there, not only scale up, but also to enable a scaling out through the cloud, the infrastructure and the networks. And so this kind of a rapid type of innovation that needs to be introduced and we want to enable, also call to what we call a cloud approach. Normally when we talk about cloud native is mainly about principles of the application themselves and how applications are delivered by leveraging the cloud. But cloud principles also require a network that can support them and can support those principles in order to enable delivery. So this is kind of the space that we are looking at, from the business requirements and the business need to a new network which is supporting cloud type of deployments. And through this, if I'd like to go to a few examples here, just showing what does it mean that the platform which is evolving need to evolve. If you look at this diagram here, if you look from the, don't know if I have here, yeah, probably there is something here, from the edge to the core, to the data center, there are multiple requirements, and the requirements are kind of changing throughout the network. So when we talk about 5G, more and more services are moving toward the edge, and the level of density, connectivity, connection density, throughput, etc., is growing, and the implementation are becoming more and more distributed toward the edge. So the requirements, when we are looking at this entire network, you can see that the requirements from a platform and what platform needs to deliver kind of changing from the edge to the core. So you can see here some examples here looking into latency and capacity. So for example, at the edge, there are application and services that are requiring ultra latency, which is like very small latency latency. Here we're talking about less than 1 millisecond. This is very, very constraining, very tough requirement on the equipment and from a service perspective. As we move toward the data center to the core, to the wireless core, and to the data center, these requirements are becoming less harsh. But these are kind of requirements that when you develop a platform, you need to accommodate these kind of requirements. And you may see that from a capacity perspective also, the change that is happening in the industry, where the capacity in 2017 here, you see some numbers, and you can see how the capacity is increasing in the edge and in equipment, which is supporting the edge. The capacity requirements, in one hand, need to increase, so more and more capacity need to be supported, while the cost constraint and the cost per bit needs to actually, we are looking into reducing the cost per bit. And on the data center, you see that here you can see here, where is my little thing here? You can see that the core was, you can see that the capacity requirements are actually relatively getting more reduced. So in order to support this, the approach that we are addressing here is that you do need a per location. The requirements per location are different, which means also that the platform that are deployed across the network are also not the same platform will be deployed across the entire network. So different platform requirements across the network. If we are looking at the roadmap of platforms, correct? So we are talking about network transformation and the platform that are to support this transformation. So if you look at this chart here, you may see that, the platforms that are supporting, you see a spectrum of different platforms that are serving different deployment models. There are different deployment models. And this platform need to address first and foremost, like the requirements that I presented in the previous slide, which has to do with capacity and latency, and at the same time to meet the telco's requirements for security and robustness and the predictability, correct? This is in one hand. On the other hand, you see that we are transforming from platforms that are based on that are more vertically integrated. These are the ones that here are indicated as the bare metal standard type of server, to more into deployments of platforms that are more serving or addressing the cloud principles. And if you look here, what you see, we see that we have platform, the hardware platform itself, that needs also to support these different performance requirements and the reliability requirements, as mentioned before. But on top of this, you can see here that there is the transformation into a world of supporting VNF and CNF, meaning applications that are VM-based, applications that are container and cloud-based. And what we see over time is that we are kind of seeing that a more hybrid type of model, as a service provider will need to actually accommodate an environment which is a mixed environment of CNF and VNF, container and VM, kind of living in a hybrid way, side by side. And I want to just, since we had the CNTT discussion before, I want to indicate that also when we are looking at what CNTT is addressing from a telco perspective, there is the reference architecture that CNTT is discussing. You have reference architecture that are referring to more Kubernetes-based type of reference architecture. There is another one, which is a VM-based reference architecture. These are definitions by CNTT, but each of those also have a the thinking is that each of those will also support a mixed environment of applications that are either VM-based or container-based. So there are multiple models to do so, and this is a complete, a whole presentation can be done just on this topic. So again, as I mentioned before, multiple type of platform, and with the 5G coming, we see more and more emphasis that they need to be addressed in order to address those 5G and edge requirements. But I want just to also make the point that if you notice, the arrows on the slide are all going in parallel. So in principle, there are multiple, there is a diversity of customers, diversity of deployment models, diversity of needs. So it's not that we are seeing only cloud native, like a migration of everything into cloud native, but over time there will still be multiple type of deployments. Also, bare metal is not going away from the world, and this is still something that we see happening in parallel. So all these need to be addressed. So actually, everything that I've mentioned so far is just leading to the conclusion that it's kind of complex. And there are multiple type of platform, multiple type of requirements, and how we were looking at what is it that we need to do in order to ease this transformation and in order to work with the industry in order to enable the delivery of such a large amount of platform with, that needs to meet so many different requirements over the next few years. And the way we are looking at this from Intel is that, of course, Intel is a hardware company. We are delivering silicon. We are delivering a memory, NIC cards, a lot of hardware products. But we have also a lot of investment in software and in software development. And we are working with the open source community in order to advance the adoption of this transformation in the market. So out of this, wanted to share with you this slide here. In order to, first of all, we identified what are the main gaps in the industry in order to drive the development and the adoption of new platforms and new infrastructure that will serve the transformation. And like big buckets here, we say one thing, automation is one. Automation refers to the fact that I mentioned before, shortening the life cycle management, enabling more automated type of deployment that make it faster, testing in a more automated way. Automation is something that is adopted in many. There are many aspects to automation. The second one is here, which is called standard interfaces. And I don't know, maybe standard interfaces, not the best way. Maybe it's more about VNF portability. The fact that service provider wants to develop VNF, develop application once, and be able and deploy those applications on multiple platforms, on multiple environments, containers or VM, etc. And this requires standard interfaces. Standard interfaces are applicable in multiple layers of the software stack. Platform security. This is another thing which is required. This is in particular about platform security, not about security in general, resource management. What do you do when you have multiple services that are competing on the same resources, and resources need to be allocated in a way that those application or those workload that are more prioritized or more sensitive to, let's say, latency requirements are being prioritized. So resource management, and again, resource management can start from a very low level, even on a CPU, on a core level, or it can go up to providing a resource management for memory and for servers, which servers need to be allocated. Then data plane acceleration about ensuring the performance which is needed in order to deliver services. And last but not least is about cloudification and supporting this transformation that I mentioned before. In particular, I will mention here the support for containers in a network environment, which is a focus. In all those industry gap, what we are trying to do, we are providing, first of all, scalable. We are looking into providing scalable platform, those that are scaled out and scaled up. And all of this, we are trying to demonstrate how this is also possible or can be delivered on Intel platform and different hardware and solutions that are delivered by Intel. In all this work that we are doing this in the community. All the software that we develop is open source software that we are developing in the community. You can see here some of the, not all, logos that shows like our work in OpenStack, in Kubernetes, in OPNFV, etc. Work with our partners in collaboration, and at the end, after doing all this effort, we are delivering adoption tools. And back to our story on experience kits, and experience kits are the way for us to communicate how these industry gaps can be delivered through your development, or what you may want to adopt if you are an architect, a developer, etc., what you may want to adopt. And here you see the Network Builder website from Intel, that if you will go to this site, you will find this library of documentation and of experience kit that we are offering in order to ease the adoption. For this presentation, we decided to give you some examples that MJ is going to deep dive a little bit more into, some more meaty examples of the work that we are doing. And out of all these industry gaps, here we are looking into cloudification and some of the work that we have been doing around Kubernetes in order to enable Kubernetes for networking. So specifically, Kubernetes for networking. But because if you are looking traditionally into Kubernetes, Kubernetes was mainly designed to support or to deliver web services. And when we are looking into networking, the requirements are completely different. And in order to deliver NFV, it's different requirements that are needed, both from number of interfaces that need to be supported through a platform, through the security requirements are different, capacity requirements are different, etc., etc. So here again, looking just into this one bubble called cloudification and what we need to do, we were looking at what are the industry gaps, and we came up with those 5 industry gap called, one of them is Kubernetes networking, which has to do with how networking support in Kubernetes, how we can, in these containers and Kubernetes environment, we can support data acceleration and support these higher capacity needs. so enabling DPDK type of applications, etc. Resource management, I mentioned before, again in a container environment. Telemetry, how we expose telemetry from the platform up in a way that we can still serve or save the the cloud native principles, where we try to have a separation between the application layer and the platform layer. So try to create a more and more abstraction between the VNF and the platform layer. And ease of deployment, we came up with some tools in order to enable automated type of deployment of our reference architecture, etc. And these here are just a list of solutions that, this slide, I started it like, I think more than a year ago. It was very short. And then all the time we're adding more and more capabilities, more and more solutions. And all these solutions are getting more and more rich and more adopted by the some of the in the industry, by some of the vendors that are out there. So again, there is another experience kit site which is more dedicated. You can see it here, experience kits that are available under a container experience kit. So there is even, so you may see like a more general approach of experience kit for like a big bucket, and there some more on the container side. And from here, I'd like to just give the baton to MJ to go a little bit into the details of some of those of the work we have done.
Thanks, Dana. So why don't we all give a big round of applause to Dana? Fantastic job, right? And what do you see here? Do you see goodie bags? That's the goodie bags he's giving to all of us. So how many of you are familiar here with the DPDK, NFV, hands-on? Okay, very good. Almost half the people, right? So how many of you are like done cloud? To see two links there, okay? So let me see whether the links, if you do.
Excuse me,
Yeah.
before you keep going.
So you do see network transformation experience kit, as well as you see container experience kit. That's the two things he talked about, right? So if you can think of network transformation kit as a bigger umbrella, and then you can think of container experience kit as one of the child, right? And then in the future, possibly you are going to have multiple of that. Any questions till now, before we get into deep? How much more time I have? How much? 20 plus minutes, okay. Any questions till now, before we go further?
So why is it hierarchical that you have to have network transformation experience kit before you can apply the container experience kits?
No, there is no dependency here. This
Okay.
is just the way we structured it in order to, it's not about deployability, it's about what is the problem that you are trying to solve. So then you go to this, it's like a library,
Okay.
like a library of information, and we just structured it.
So like if I say hardware performance awareness, HPA, does it come under the lower one or the higher one, bigger one?
Okay, so we will go over that. So network transformation kit, you can think of us having VMs also, whereas now container you can think of focusing on containers. So all the EPA and all those things we will talk about how that we are doing in container. That's a very good segue to the next file. So if you see here, you can see technologies like DDP. How many of you are familiar with the word DDP? DDP stands for Dynamic Device Personalization. So right? That is completely orthogonal to whether it is container or not. So that's how you are seeing that in network transformation. Similarly, we have something called SSTBF. I'm not going to go over those things. I'm just telling you that those are falling in the other bucket. SSTBF is more like if you are going in a plane, there's a first class, there's a economic class, and there is a business class, right? Similarly, you can have your tasks, which are all demanding you different performance. You can select out of 72 cores, some number of cores to be first class. They will run at higher frequency. Some number of things will be running at slightly lower frequency. So you can position your cores that way. That's the SSTBF. So the point is, I'm just saying these things so that in case some of these things click for your interest, you can go and watch these videos. Very much lot of effort Dana and the team has put in together to create these videos for you to consume. That's why the title is Get the Experience, start with these videos. Okay? And then if you see the container and Kubernetes video, you are talking about 1, 2, 3, 4, the bottom 4, they are more like an episode. Episode 1, episode 2, episode 3, episode 4. The first one is going to talk about what pretty much she covered till now. The network transformation, architecture, why, motivation, need, the problem statement, right? Those type of things are in the architect first video. Second video will go into things like, why don't we show one video, right? And then second video will talk about the technology, right? What are the gaps? What are the gaps in container? Because the container is coming from ease of use, scalability, right? Elasticity, whereas the DPDK and NFE are coming from performance, right? How do we match both of them? Those are the things that Intel adds value. Now your container need not be only ease of use and scalability. It can be high performant also. How good is that? And that's a gap, the solutions, technology that video number 2 talks about. Video number 3 talks about how the Ansible playbook and then Helm files, how you can go and install the Kubernetes, and we have guide for you to take maybe one machine, one server, and then go through step by step. It's not just to talk the talk, but you walk the talk, right? You take it and you run YAML, you run playbook Ansible command, and you see all the commands and the screenshots are shown in that video. You'll be able to verify whether what you are doing with the Ansible scripts, the YAML file really has done what you are expecting. So that's the 4th file which will verify. So these are the bare metal container reference architecture videos. And then the technology focus, there's something called MULTUS, which we are going to go over today. And then topology manager, which also we are going to go over today. I have some, we have some show and tell to you. How many of you remember the story about the 6 different or 5 different, disjoint people touching different parts of the elephant and identifying what it is? So we will talk about, when we talk about container disaggregation, who is going to take care of holistic view? So these are the gaps, and we are going to look at those things, okay? Any questions in these videos? Anybody? Have you all taken the picture of this? So that you can go and watch tonight. And we are expecting questions from you tonight. Okay? So, okay, let us go through and then come back and show the video. So today the discussion is, as we said, if you go clockwise, in fact, the first one is container bare metal reference architecture, and we just went through those 4 videos I talked about, right? The aggregation of those 4 is what that is, and you do have a guide which has step by step for you to do a hands-on. Just take a server, configure it as controller, as well as pods, workers, as well as Ansible host. You will be able to run all of them, right? And if you have 2, 3 servers, then you can specify one as a Ansible host, other one as a controller, and then the third one as a worker, and you'll be able to execute the same guide with the different configuration parameters to achieve the whole setup. So that is the leftmost one. MULTUS, we are going to see MULTUS in this today. And then topology manager, we talked about that, right? The disjoint view versus holistic view. And then the bleeding edge, right now under development. If you see, it's all more chronological order. You can think of container bare metal reference architecture as a base foundation, and MULTUS is a needed fundamental unit. And these things are all open source. And then if you see topology manager, it is available in Kubernetes 1.16. Where it is? Where is the highlight? Oh, okay. Did I do something? Okay. So yeah, this is the Kubernetes 1.6 here, right? Topology manager. And then that is under development, okay? So you are going to go over the 3 elements here: topology manager, MULTUS, and container bare metal reference architecture. Telemetry aware scheduling is a homework for you to contact us with questions.
Just wanted one point here to say. So again, MJ is talking. It's important to indicate that all the efforts are open. That everything we do is open source. So, for example, the telemetry aware scheduling is going to be open source in the next couple of weeks. So it's accessible for everyone to kind of get and try it. Nothing is tailored around a specific for a specific vendor or anything like that.
Correct. That's the power of open source and internal.
And there is some links into, if you go into the experience kit, there are some links into the GitHub where the information resides. So that's how the experience kit and this collateral can help better understand what each of those. We just give you here like a snapshot of what it is, but there is more to read there and to understand.
So are you able to see here? Yeah, this is what we're talking about. Container reference architecture, the guide I am talking about is here. Kubernetes networking, and Prakash was asking about EPA, telemetry, what is under work, and then demo and training and demo link. If you click here, you will get to that all the videos, right? Part 1, part 2, part 3, part 4, topology manager, and all of them. Okay. Okay, so that's what here available, and then a lot of effort has gone into, because we initially had just our own application notes, but then this one puts everything together. That's why we showed you the goodie bag, right? You have the demo, you have the technology, you have the guide, you have the videos, you have the whole recipe, right? So that's what this file talks about. So what really I get? You get hardware bill of material. Why that is important? Because if you have to replicate what we have done, we need to tell you what is the configuration of hardware. How many NICs, how many CPUs, what server, what version of the BIOS firmware. That is a software bill of material. And then how they are connected. You remember I was telling that you have Ansible host, and then you have the controllers, and then you have the worker parts. We're talking about 3 controllers, 2 worker threads. So those are the configuration and how they are connected topology wise. What is the kind of control plane? What is the management plane? What is the data plane? How they are connected? Those things are provided to you. And then installation playbook, not just all these things in a paper, but really some scripts and playbook for you to execute and realize in your own home on a Saturday and Sunday. Right? You have a system, you have an internet connection. You can pull it, right? And then complement material. If you see stacks of guide, right? 1, 2, 3, much more, many more application note type of thing with the screenshots. What we did, what we got. So that way you give it and then you compare it, right then and there. Not only that, you are able to see software, control scripts, and then benchmarks, what we got. All of that is available to you, right? So what is the benefit for you? For you, it's like a quick ramp up. It's like you took some course and then maybe within 3-4 hours, you got to know the key things and you also got your hands dirty, right? So awareness, education, and adoption. The more confidence you get, you are going to adopt. How many of you are excited by seeing these things, right? Because these things take a lot of effort, tuning, right? Even if you want to do something in
Yeah, excellent. I think, do you have a hosted version of this, or one has to deploy in their own data centers or in their own house, or how does it work?
We do asking do we have
Whatever
hosted-
this is available, is it available online so that I can go and say, hey, this is the 5th server, this is the 4th, I want to use this as a session, and then
You are more like Amazon Web Server type of thing. Do we have something already made it available for you? I will say maybe yes and no. The reason I'm saying that is all of them are GitHub, so you can pull that from that way, each individual component. But you have to make yourself a
okay.
platform.
So servers have to be our own, basically.
Yeah,
That's
correct.
what it is. So we can use it on, let's say, Rackspace. I can go to Rackspace,
Yeah,
shoot up some servers, and then use this.
you should be able to do that.
Okay,
Yeah.
thank you.
By the way, for you, because you were a CNTT before, the reference architecture that you see here for container is the one that we contributed to CNTT as the baseline for the Kubernetes reference architecture. So
Cool.
we turned over and was doing that.
So in the CNTT you got baseline bronze, silver and gold, and so is that matching one of those? Okay, thank you.
So now you have the proof in the pudding.
Architecture is, for Kubernetes is still in the works, correct? And this is more specific with the BOM, which is an Intel BOM. The reference architecture in CNTT is neutral, so you can use any hardware. But the principle and how it's built is this is what.
So are you able to see this, the whole reference architecture here? Right now we are now going to go through the clockwise, three of those 4 blocks, okay? You are now hitting the first block. So you are able to see the components like, the top 2 you are able to see the worker nodes, and then you are able to see the master nodes for high availability, and then you are seeing the Ansible host where you run the playbook, and you are able to see various components. How many of you are able to read? Maybe it's very small, I will read for you. SRIOV plugin, user space plugin, MULTUS plugin. These are all the value add that we talk about in terms of the features and the solutions, technology solutions we provide to fill the gap. What's the gap? Ease of use and performance, both coming to you, right? Any questions on this? And you are able to see here a link. Every page possibly will have a link, so you want to go and take that. I think I have 12 minutes, I'm going to wrap up fast. Okay, so you asked, right, okay, what are the things that document does? Exactly, this is what you get. You get setting up of the infrastructure. So there are 3 steps what we are talking about in the BMRA. One is the pre-configuration. What it means is whether it is Ansible host or it is controller or it is worker pod, doesn't matter. There are certain things minimum you have to do for Kubernetes environment, and that's what we mean by pre-configuration. It is done on all the machines meaning host, controller as well as worker thread. That is step number 1. Step number 2 is KubeSpray doing high available controller creation. So now out of all the things you have done the base Kubernetes setup with pre-configure as step 1, you move to step 2 where the KubeSpray identifies, okay, these are the 3 high available controller I need to do. So here I go and do only that. Why we use KubeSpray? Because that's a mature technology. Getting a controller is mature technology. So we just want ease of use pretty much. Some of them you can see using Helm chart. Now on the right side, next thing comes is the plugins, because by default Kubernetes doesn't have performance optimized things. So that's where we are bringing EPA and all the other resource management, which are all performance sensitive. And that's a form of plugins. I think you learned about a lot of terminologies in the previous presentation by Prakash, where he said CRD, right? Third party resource, TPR became CRD, and those things are being used as a plugin here. Okay? And if you see here, Dana has put this arrow underneath saying Helm chart. So I think you also heard in his discussion about Helm chart and the benefit, you get all those benefits here, right? So again, you may have questions, but definitely take that guide and then do it yourselves, then you will be the master, right? So let's go through the first one. So now we touched upon out of the 3 blocks, we touched upon the first one, right? Container, bare metal container reference architecture. Now we are going into the main technology inside. Okay, why MULTUS? What is the need? Now, if you see the Kubernetes, right? For ease of use, what they have done is they have defined a pod, they have defined a container, and they defined a network interface. When I say this, I'm showing you purposefully only one network interface that by default Kubernetes has, correct? In that one network, you are passing control, management, data, plane, everything. It's like you are going in a fast vehicle and there's a big truck before you. How will be your performance? And that's how the traffic is going to feel in a native Kubernetes. You have one network, right? Whereas if you're talking about high performance computing or even regular high performance telco network requirements, you're talking about data plane need to be separate, control plane need to be separate, and that's where the MULTUS comes. So in a summary, it is giving you are extending that single network to multiple network, where now you can give priority to what you want. If not, it is not even possible. So this is enabling very much a basic lack in the Kubernetes. Okay. So what are the use cases? I have just put 4 use cases. These are use cases which necessitates to have multiple network. If you don't have it, you cannot even have these things. That means containers cannot even have these things. Because MULTUS is bringing that capability, all these applications are now getting live and possible to live on container world, thanks to MULTUS, right? So how, okay, so when we say previously before MULTUS, only one interface, right? The CNI is container network interface. You pretty much have ETH0 and Linux bridge, that's it. Whereas once you have MULTUS is now taking that CNI and now becoming a parent, and now it can have multiple child, and one child is the poster child Flannel, and then now it can have DPDK, which is a user space. The previous one is only kernel space. Now you can have in user space DPDK SRIOV as well as a kernel SRIOV. So the point is, the key takeaway is control plane, management plane, data plane separation, right? And is there a proof? Is anybody adopting that? Here is the example, right? You are seeing OpenShift. How many of you are familiar with OpenShift? Red Hat OpenShift, right? Okay, so it's like Kubernetes plus, right? So they are adopting that, and that's what you are seeing in the left without MULTUS, and on the right with MULTUS, Mac VLAN, CNI, how it is enhanced. Okay. So go and look at that ONS North America 2019 Red Hat and Intel presentation. You will see that. So now we have touched upon the BMRA, right? Reference architecture. We touched upon MULTUS. Now I think I have 5 minutes, so I'm going to touch upon topology manager. What is topology manager? So let's say you have node 1 here, and let's say you have node 2 here, right? 2-socket system, and now you have application, and that application it needs memory, it needs device, and there are something called resource managers that natively comes in Kubernetes. CPU manager, device manager are the names. So that's where I talk about this, right? The people who don't understand the big picture, they touch this and they say this is a fan, right? Or this is a trunk, or this is a snake. But then somebody has to tell them that no, it is none of that, it's much bigger than that. That's where we need them to communicate to each other. And the topology manager is that communication mechanism between those individual components, which is a device manager or the memory CPU manager. Thereby it says your device manager is sitting in nice device like see, what do you mean by nice device? Devices like GPU, Intel security, quick access technology, compression, right? Network IO, your SmartNIC, your FPGA. The basic default Kubernetes doesn't even do anything with that. So there you need to call this device manager to find out where they are located and what their characteristics are. So you are seeing a workload. I was just showing, jumping 2 sockets and showing this workload is now straddling across 2 sockets, meaning one device comes and tells, oh, this is CPU you need to use is in socket 0. Oh, device you need to use in socket 1. Now application is straddling across 2 sockets. What happens? Performance drops, right? So that's where topology manager comes and tells, this is what we talked about, right? You need to think global and act coherently, meaning the story, what we know, if you extend it, thereby they can communicate among themselves, then they will all get big picture. Each one will not say it is a snake or a trunk. They will say, all together it's an elephant, right? So here is what that is being done. Instead of piecemeal finding CPU in socket 0 and then device in socket 1, what we are telling is, well, the workload better use both devices and socket in same CPU and same socket, thereby that overhead is not there. That's what the topology manager achieves. Okay, and here are some links that 1.16 has. And as we said, the CPU manager and device manager, the two different one, it gets the hint and then it arbitrates. Let me step back and ask you a question. See, what we are doing is kernel, which was box based, now it is addressing disaggregated container cloud. That's where all these problems are coming. Right? Disaggregation is great, but then when you have to work holistically, you need this type of aggregation component, and that's where this comes in. Okay. So the key takeaway is, as Dana was pointing, Intel is collaborating with the industry to enable advanced solutions for transforming network, enabling software by open source. Right. That's a powerful to scale, and then experience kits gets you to experience at a much faster ramp up, and then go and deploy and get the belief in that. Any questions?
So does device manager handle multiple cores from multiple CPUs and GPUs and NPUs and whatnots?
Yeah, the default device manager does only to a limited level. It doesn't have the holistic view. That's where the topology manager fills the gap. The device manager may come and say, yeah, this GPU is in this place, this FPGA is in this place, it will tell. But then application needing CPUs of this characteristics and a device of this characteristics together, that device manager cannot tell. For example, if I want to use a vector instructions CPU and I want to use a GPU along with that, the device manager will not know about where the AVX 512 CPUs are located. That CPU manager will know, but device manager will not know. CPU manager will not know where the FPGA or GPU are there. That's why the reason why this happens is Kubernetes wanted to simply have a very basic things like CPU and memory, nothing to do with the devices. That's where device manager comes in, but it has a gap.
So are there equivalent of SYCL, what you call, for the template, C++ templates, which does handle SCVP, whatever you call as scalar, vector, and what is that?
AVX.
Yeah, no, AVX is 512, that is instruction set.
Right.
I am talking of CPU for scalar, GPU for vector, and then you have got another for, I think, something like matrix, and another for space. That's the new architecture which you are defining, I think, under Scuttle, which is what is using this. So do you have any equivalent of other than C++ templatization for multi-hybrid usage?
Right now, we can talk
Maybe
offline.
we can talk offline.
We can offline.
Yeah,
We can talk offline. Yeah. I hear the bell. 1 minute. Okay. Dana, do you want to come and wrap up? I think we have 1 minute. Why don't you come and wrap up?
If there are any questions.
No, but call to action. Anything?
Yeah, the call to action was there. The call to action was to go to the two websites that we send out and go check it out. And please, you have our contact information, so you can always get back to us and we'll be able to address your questions. But really just go and try it out.
Yeah.
I think reading the video makes it easier to those that don't like to read like me, and whoever likes to read, there is a lot of documentation and pointers into the GitHubs and where some information, some engineering sites as well. Depends what level of data you want to get.